Hey everybody, this is Larry. This is day 11 of the February Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this poem and how you're doing in general. And of course, today, right now, I'm still in Medellin, doing terribly. I gotta do better about that. But hope everyone's alright. And today's poem is gonna be permutation in string. So given two string S1, S2, return true if S2 contains a permutation of S1 or false otherwise. Okay, I mean, this is just, well, you could do it in a couple of ways. You could sort and then two pointers. You could really just look up, you could really just, just do a character count and do a subset of it. That's pretty much it. I would also say that this is one of those problems where, as I always say, it may seem like it's magical, it may seem like I'm getting it really fast, and okay, maybe I am, but some of it, or a lot of it, or most of it even, is that it's just experience, it's about practice, about seeing similar problems, and permutation is something that, for whatever reason, in competitive programming, it does come up a lot. Maybe it's just because it's fun to think about how to solve these problems, but as a result, you do see, you make the same observation multiple times, and you have some tricks up your sleeve, say. That doesn't mean that you should memorize the tricks. It means that you should spend the time to explore these problems so that you can like come up with these tricks per se without memorization, right? Memorization is harder for me. If you ask me, there's so many things you can memorize, but if you have an idea, then you could kind of go down the same path every time and hopefully get it right every time. So yeah, so I think that's all I have really. Um, I wonder if I could use something like collections.counter. I don't know if there's anything, um, like I wonder if there's anything cute about like a subset in this that I could abuse. I mean, you could definitely check it for whatever, which is that, let's see, that means that S1 has to appear in S2, right? It's a short idea. So that means that you could, maybe there's a one-liner thing for it, but we can do this that, let's say character one, we have one of X is greater than or less than or equal to of X for X in C1 dot keys, right? Something like that maybe. Let's give it a spin. Basically, this is saying for every. Whoops. Why did I write? I think I wanted to write a different thing. That's why, but this should be okay. Basically, it's saying that for every character that's in S1, it appears in S2 more times in S2. But it seems like I got something wrong. Maybe I misunderstood something. Okay, so that's good. A and B, but B and A. Damn it. Why is that false? Maybe I misread this though. Sorry. If that's the case, then you get a freebie. I mean, that's true if one of S1's permutation is a substring. Okay. Maybe I misunderstood this. And in that case, I do apologize. So I did. So there are a lot of bags of tricks for permutations. So this is the same thing. So yeah. So we can play around with it again. So I think I misread this one. I thought that you can also permutate S2. So, and apparently that's not the case, but this is what you would have for that one if that was the case. So okay, so I'm wrong here because I misread it or make it correct because S2 cannot be permutated, right? So you have to get a substring. So in that case, again, you just have sliding window. And the sliding window is that, as you move from left to right and you keep track of, say, in this case, two characters, because S1 has two characters, you want to see that it matches everything in S1. I feel like we've done a similar problem to this recently. So I don't know, but I could, but yeah, but I think sliding window is the idea, and with that we can slide. So let's do that, and then the idea is that we the idea is that the idea is, yeah, yeah, the idea is that you keep everything inside a certain window, having every character of S1, and if you check that in my case it'll be O of 1, but if you could check that in O of 1 time, then that'll be pretty good. So yeah, so then here we do a sliding window, as we said. We have let's say a current deficit, if you will, of collections.counter of S1. So basically the idea is that when this current counter when it has no elements, then we're good, right? So then now we go for, so you have the left side of the thing and the right side of the thing. So for right, in range of from 0 to in this case it's not n, it's actually, let's say m, where m is equal to the length of S2, right? And then left of this window is going to be right minus n, maybe. Let me see. I mean, I'm always bad about off by 1 to here, so I always try to think, and the way that I do it is by looking at a number, right? So if right is here, then the left should be here, so I think that should be good, as long as you follow through what that means, right? Which is to say that left is exclusive and right is inclusive, the way that I'm doing it. Yeah, you may debate on it. But okay, so let's say now then, first of all, we want to add this to the set, kind of, and by adding to the set, I mean that we remove this thing, right? So it's S2 of right, kind of. So let's check, right? So yeah, if I have to be really careful here, because if I remove something, I want to be able to add it back in the future. But if we are sloppy about it, then this may not be Gucci. I think there's okay, let's just actually let's just say we add another thing. Yeah, does this change this into the list? I don't actually remember. Or maybe let's just do this, right? This will be a little bit clearer, I suppose. So yeah, so now let's say the current character is this, then we can do something like if because if it's not in scene, then we don't even care about it. If it is in scene, then we can do something like yeah, f of current of c minus 1, and then the other c, we can do it again. It's going to be the one that's on the left, and in this case we're removing the one on the left, right? If left is greater than 0, then we remove the one on the left. Yeah, and here we add this back because we care about it. Oh, I missed it though. And so something like this, right? And of course, to make our computation easier, we have to do something like if current of C is yeah, okay, you're 0, then we remove it. I guess technically it could get into negatives, so in that case, well, I guess you can get the right answer anyway, but here I guess we should do this check as well, because it could be negative and then just adds it to make it 0. And then at the very end, if if right is greater than or equal to n minus 1, why is this? Because here, if n is 2, then at index 1, we process 2 characters, right? So that's the beginning. And then we just basically check if the length of current is equal to 0, we return true. Otherwise, we return false. I really feel like we've done something. I don't know if it's, I feel like we've done a similar problem recently. I don't know if it's like on a contest or anything like that. So, okay, so I was able to at least correct it for the input. Let's try something like, we see, okay, and then now we have a, right? Would that be be I don't know, something like that. I guess it'll be just force. But I want to make I want to so this having the right answer is not good enough for me. I actually do want to print out the current to see if it has negative values, because it should have negative values, and that's fine, because I don't want, what I don't want is that, like, if it kind of chops it off, for example, then it would be really sad, right? In the sense that if it chops it off and then, like, it may affect future states or something. So that's basically what I was looking to avoid, right? Okay, so this looks pretty good. Let's give it a submit. Hopefully I get it right. We'll see how I did last time as well. Okay, sweet. Yes, 682 days now. Sweet, sweet, sweet. Yeah, so what is the complexity here? Well, we already have n and m, so of course this is going to be O of n, this is going to be O of n as well. For O of m, this is obviously O of m for this O of m number of iterations, and here everything is O of 1, right? So that means that total this is going to be O of m. So in total this is going to be O of n plus m, right? In time, and in terms of space, it's what did I say? Did I say anything weird? Because this is only 26 characters, or, well, in the lowercase, but otherwise it's going to be O of alpha space, which is, you know, like the size of the alphabet, which I hope makes sense, and I don't have to explain that much. But yeah, that's what I have for this one. Let's see what I did last time. Was yeah, I mean, I actually, okay, last time I was less lazy. I drew out the, oh no. Okay, I mean, I guess we did the same thing, except for that this is more expensive. We did the same idea, except for that we use an array of 26 elements, where here, this check is literally O of 1 instead of O of alpha. So that's a little bit faster, up to 26 times faster, if you will. So that's, you know, but that said, the submission time is slower, so I don't know. I think they just add more tests, but it could be, I could be wrong, I don't know. This looks pretty sweet though, so I don't know. But yeah, cool. That's all I have for today. Stay good, stay healthy, to good mental health, and I'll see you later. Bye bye.